Hey guys, happy Monday. Back at you for some more math fun. Your quizzes should be in the grade book or will be in the grade book today. Um, and then I know that some of you I saw tried to turn in a bunch of stuff, missing work, because I sent out progress reports on Friday. Remember, you can only do missing work within a week. If it's or later than a week, you can't. You can do it all you want. You just can't turn it in for a grade. Um, yeah. So if you guys have any questions about that, let me know. If your parents got an email, make sure they email me back, unless they want me to continue to email them and call them because, yeah, that's how that has to work because I have to hear back from them. Okay. And I'm not trying to, call your parents 58 times before Christmas here and bother them. So obviously our test is coming up before Christmas break on Unit 3, which is like the most important test of the whole year. And that'll be a really good opportunity for you guys to bring your grades up. So make sure that you're coming to office hours and asking questions if you have any questions. Or make sure that you're emailing me, sending reminds, that kind of stuff, so that if you need help, I can help you out. Obviously, I'm not going to know unless you tell me, okay? We are going to talk about qualitative graphs today for a little bit. Actually, like this whole week. But qualitative graphs are like what's going on if I don't have numbers in my graph. So I'm just looking at the behavior of the graph, if you will. So let's say we had a graph about, we have some time in seconds, and we have the distance above the ground in feet. Okay? And let's say something looks like this. And I'm going to have a line that does that. Hang on. Something like that. Well, we can kind of talk about this graph, even though it doesn't have numbers on it, and we can get some serious information here. So for example, we might break it into intervals. An interval is just a part of the graph. So a decent place to think of the intervals here are this this climax point, if you want to think of it that way, or this vertex. And so we kind of have what's going on in interval 1 and what's going on in interval 2. So when something is going up like this with like a, even though it doesn't have to be linear, because if you notice this is non-linear, right? This, even though we would think of it as like a positive slope, we would still consider this is going to be increasing. Okay, so interval 1 here is increasing, meaning that as the time is going up, whatever this thing is also going up. All right, so it's going higher above the ground until it reaches some point, which is right here. And all of a sudden it switches from increasing to now, maybe we would call this thing a negative slope, even though it's not a straight line, so we wouldn't use that kind of terminology. But what we would say is that it's definitely decreasing. Right? So on this side of the bar here, I see that it's going down from left to right. Over this entire interval, it would be decreasing. And so we can kind of say, well, what do we think's going on in this situation, right? Now, we could, if we had some kind of general information, we do know that this is 0, 0 always, whenever these two meet. So we started with some height. This thing went up until it reached some point, and then it decreased kind of quickly. This might be a really good graph for a quarterback throwing an incomplete pass. downfield, right? It starts up high. It didn't start off the ground because I have it in my hands up here. He throws it, and it's over time. The ball's getting higher off the ground until we reach some point where it's going to fall really quickly, hopefully into my receiver's hands. But as we notice, it's going to actually touch this bottom line, meaning that at some point it did touch the ground. So we can say that this is an incomplete pass, or possibly the receiver fell, as they called it, one of those diving jobs or something like that. But there's no kind of weird squiggle or anything to kind of show that, so probably just fell and hit the ground, okay? So we're just going to kind of look at these kind of things and talk about these intervals, all right? Let's say we had, let's go speed and time this time. So we'll call this one time. The x-axis is typically time in minutes, and we'll say this is speed over here in miles per hour. So what we're going to have is something like this, something like this, something like this, and then this, and then maybe that, right? So let's look at what's happening over these intervals here. And again, we kind of have a couple areas that look like really good breaking points. So something changes here, something changes here, something changes here, and something changes here. So these are all going to be intervals of our graph that we're looking at what's going on in those intervals. All right. So let's look at interval 1. Well, it looks like we start at 0 minutes. We are going 0 miles per hour. And then over interval 1, we would say this is increasing. So what that means is that my speed is increasing. I am increasing in my speed, but not only am I increasing in speed, it's at a constant rate. Now, how do I know that, right? Because this line is a straight line. It has a slope, right? This is linear in interval 1 here. So that means that I am constantly increasing at speed. Maybe I'm going 10 miles per hour more every minute, right? But this would be maybe like when your car's coming out of your driveway, or maybe you're parked on the street, and you're going to just increase to the speed that you want. Which brings us to interval 2. Now my speed is not increasing, and it's not decreasing. Interval 2 is what we call constant. This is where my speed is going to stay the same over a certain period of time here. All right, so if it's a flat line like that, we call that a constant interval. In that interval, our speed is going to remain the same. So maybe this guy's getting on the highway, he's getting up to speed. And then he gets to 65 miles per hour, and he follows the law, right? Because he doesn't want to get a ticket. And he is going to go exactly 65 miles per hour for a certain amount of time here. So if I get a flat line, that's kind of this idea of my area here is constant for interval 2. And then we see interval 3. So interval 3, all of a sudden, I am decreasing in speed. So maybe I hit a new speed limit, right? I know you guys really don't know roads and stuff yet because you don't drive, so you don't care. But if you go out Route 20 towards Oberlin, the Oberlin Walmart, all of a sudden that highway turns into not such a highway anymore, doesn't it? And the speed limit goes from 65 miles per hour to all of a sudden 55 miles per hour. So maybe that's what's going on here. We're decreasing in our speed. Notice it's constantly, right? I could do it real quick and have a straight line down and have a real fast decrease in speed like you pounded your brakes, right? It'd go real steep. But this looks like a constant change in speed, a decrease, until I hit interval 4, where notice it is again constant. So now we're cruising at the exact same speed. the whole time. Now, it's not the same speed we were cruising at before, but again, we're not increasing, we're not decreasing. So again, we are at a constant speed. So maybe I changed my speed limit changed from 65 to 45. So I decreased constantly till I got to 45, cruised at 45, and then notice in interval 5 here, we are decreasing kind of sharply. So maybe I'm arriving at my destination and I had to throw the brakes on, and now I'm there, right? And I'm stopped. Notice that I went all the way back down and touched this line, which means my speed is 0. So I could say there, now my car is stopped, right? And this graph could continue and go on and be like, ooh, and do something like that where, oh, I was stopped somewhere. We'll call this, we'll keep going here. We'll call this interval 6. And I went inside Arby's and got, some food and stuff. And then some guy in there wanted to race me. So I was like, whatever, I do what I want. And look how fast I'm increasing in my speed out of the Arby's now, right? So I went outside and raced this dude out of Arby's, which I obviously don't condone racing. I do condone Arby's, however. They do have the meats, and that is fantastic. But that's kind of what's going on. So we're going to have a group of graphs that we're going to look at without numbers, and we're going to we should be able to come up with this idea of what is going on. Is it increasing in this interval? Is it decreasing? Is it constant? What's changing? All right, so we're just going to kind of toy with that today. We're going to work more with it tomorrow and Wednesday. And it should be pretty good. And we will hopefully be ready. We're going to start reviewing at the end of this week. And then our test will probably be next Monday, I'm guessing. It sucks that it's a Monday test, but we only have 2 days of school next week. So we're going to have to get that thing in. Okay? All right. Let me know if you have any questions. Office hours later. I'll see you guys on the flip side.